This is a problem from the review sheet for semester test. It is the last one, number 16, I believe. It has a picture like this, sort of. It's not exactly the same. Pretty close. Basically, you have a block setting on the edge of a table, and you have another block, and we're assuming this is a frictionless surface. I don't think I said that in the problem. Well, the problem is given the blocks are equal mass and stick together when they collide, how far from the table will they hit the floor? This height is 0.4 meters. This block, it's on frictionless surface, is moving 3 meters per second. Hits this one and sticks to it, then they descend and hit the floor. So this is a projectile motion problem and a momentum problem. In this case, we're trying to find delta x, how far, so we need to find all the other things. Well, some things we can already fill in here. And that would be, we know delta y is negative 0.4 meters. We know that since it's a horizontal velocity initially, that this is 0 initially. We know this is negative 10 meters per second squared. And we don't know t. So we could find how long it's in the air. We do that by using the equation delta y equals v initial y times t plus 1/2 gt squared. Of course, this whole thing right here is 0. So we're going to have negative 0.4 meters equals negative 5t squared. Now, to, of course, find the answer, to time, we divide both sides by negative 5. So 0.4 divided by 5, the negatives cancel out as 0.08. Got to take the square root of that, and you should get 0.28 seconds. So our answer here is 0.28 seconds. And so this is 0.28 seconds. All right, so to find how far delta x, we're going to have to know the velocity of this thing leaving the table. We get that from momentum. And we know that in momentum, in collisions, that momentum is conserved. So how many blocks or how many things or how many objects are moving initially? Well, the only thing moving initially is this right here, this block right here. This one's stationary. So basically we're going to have, and we'll call this block 1. We'll call this block 2. All right? So M1, the first block's mass, times velocity 1 plus 0. That's my initial momentum. Has to equal, what happens after the collision? Well, it says right here, they stick together. Stick together means that both of those masses become one. So now we have M1 plus M2, right, times some final velocity. That final velocity is what we're going to find, and guess where it goes? It goes right here. Okay, we're back here after the announcements. So here's the deal. You're not given mass. You're like, how can I do this? Well, here's the thing. These masses are all the same, so I don't really have to have mass 1 and mass 2. All I need to do is say M V1 equals 2M VF. Look what happens to my M's. They divide out because they're equal. Make up a number and put in if you need to. So I have 3 meters per second equals 2 VF. Guess what VF equals? Because the mass doubles, the velocity has to be in half. That's going to be 1.5 meters per second. That number is what goes here. So this number here is my actual initial velocity of these blocks when it leaves the table, 1.5 meters per second. Do I have enough information now to find the delta x? Sure I do. Delta x equals 1.5 meters per second times 0.28 seconds. That comes from the equation delta x equals v initial x times t. Stock market closed. All right, so if I just multiply those two numbers together, I'm going to get how far it hits. 1.5 times 0.28. That gives me 0.42 meters. So 0.42 meters. That is my answer, and that's how far this little guy goes from here to here. It's 0.42 meters.